Welcome to this activity on the programming language family tree. Now, there are so many programming languages, each with their specialist purposes. However, programming languages are related to one another, and knowing one makes it easier to learn another. And in some cases, languages are so similar that they can be substituted for each other entirely. In this activity, we'll look at how programming languages are related. We'll draw a family tree that you can use to compare and contrast different languages, potentially substituting one for another. Afterwards, we'll look at how popular different programming languages are and the market for each. So the programming language family tree starts with C. C is a low-level, compiled, procedural language invented about 50 years ago. Okay, so what does that mean? Well, we already know what a low-level language is. That's a language which is harder for humans to read, but easier for computers to read. And when we say compiled, we mean that C programs are run directly by the computer as machine code. Now, this means the code can be very fast, but it also makes for more complicated code. And when we say C is procedural, we mean that C source code looks like the source code that we've seen so far. That's lines of instructions or procedures that are fed into the computer and run one at a time. C is still used a lot today, when we might need to build programs that are very small or very fast. For instance, a tiny sensor on a noise-cancelling headphone might use C, or the cameras interpreting data in a self-driving car. But the big downside of C is that it takes years to master. So over the next decade, C was refined into C++. Now, C++ is just like C, it's low-level, compiled, and procedural, but it's easier to learn and to write. And C++ is still widely used today for high-speed games and audio programming. C and C++ dominated programming for about 20 years, and during that time, companies began to develop their own programming languages. Most of these languages were inspired by, but easier than, C++. And in the mid-90s, Sun Microsystems released their version, Java. So Java is the first high-level language in our family tree. And just like C and C++, Java is a compiled language. It's very fast and it runs directly as machine code. However, Java is also a high-level language. So with Java, programmers don't have to worry about handling the computer memory directly. So this combination, easier to use but still really fast, make Java really popular. Now, Java was so popular that Microsoft decided to release their own version, and that's C#. So those are the first two high-level languages in our family tree. Java and C# were designed for big corporate engineering firms. And C++ also inspired a smaller, easier-to-learn group of languages, and these are called the scripting languages. These included Python, PHP, and Ruby. Now, scripting languages are high-level programming languages that are easier to learn and use than compiled languages. Now, the reason I've chopped them up this way is if you know one scripting language, then there's a good chance that you can pick up another one quite quickly, because they're quite similar to each other. Now, there's one more big scripting language to look at, and that's the biggest of them all, JavaScript. JavaScript is sometimes confused for Java, and although Java did inspire some of JavaScript, they're really not similar at all. This is because Java is a compiled language, while JavaScript is a scripting language. See the white boxes and the black boxes. So on the screen, we now have the 8 most popular programming languages used today, and in the next activity, we're going to compare their popularity. But in a moment, we'll use this map to try and place some candidates. Before we do that, though, let's add a couple of up-and-coming languages that you might see on job descriptions from really forward-thinking companies. So the first 3 come out of the Java family. That's Scala, Clojure, and Kotlin. All 3 of these languages are based on Java, but there's a twist. So remember how at the beginning of the video I said that a procedural program is designed to run one instruction at a time? Well, procedural programs are not the only kind of program. Another kind of academic way to think of a program is as a giant equation that is solved by the computer. And this is quite advanced, and it's called functional programming. Scala, Clojure, and Kotlin are functional programming languages. This is a whole different way of programming to procedural programming. It requires specialist experience. I've noted it with a little FX on each of those languages. Functional programming approaches are really popular these days because you can write very fast code using them, but not every functional programmer wants to work with the Java family. And this has led to a boost in popularity of another functional language, and that's Rust. So the final language that we're going to add in now is called Go. Now, Go is an odd language. It's a compiled language, but it's intended to be as easy to learn as a scripting language. So I've sort of given it half a black box, half a white box. I've included it here because now we have the 2 low-level languages, C and C++, 6 most popular languages that all emerged roughly around the same time, and then 5 kind of up-and-coming ones. Okay, let's use this map to do some matching. Imagine that I have a Python job, but my candidate only knows Ruby. Are they still going to be a good match? Well, chances are, yeah, they are. Python and Ruby are pretty close together. They're both high-level scripting languages in white boxes, and they were invented around a similar time. Okay, let's go again. So this time I have a candidate with experience in Python applying for a job in Java. Are they a good match? Now this is a little trickier. Because on one hand, Python and Java aren't very close in the family tree. And also, Python is a scripting language and Java is a compiled language, so things aren't looking that good. However, what about if my candidate tells me that they know a little bit of C++? Well, things are now getting better. C++ is a common ancestor of Python and Java, and it kind of joins the two up. I'd definitely be happy putting a Python dev with some C++ experience forward for a Java job. Okay, last one and then you try. I have a Ruby candidate going for a Clojure job. Now, on the face of it, this is clearly not going to work. These two languages are over completely different sides of the tree. Ruby is a scripted language, Clojure is a compiled language, and Ruby is not a functional language at all. Remember, I said functional programming needs quite a lot of specialist experience. So I'd need to see some evidence that this candidate could write Clojure code before putting them forward for this job. So that's the programming language family tree. Okay, now let's practice using it to match candidates to roles. Or you can take a look at the relative popularities of these pieces of tech and where the job markets are hottest.